So the unit circle is a circle, and it's centered at the origin. And by origin, I mean this point right here, 0, 0. The reason why it's called the unit circle is because it has a radius that is 1 unit long. Trigonometry is all about this unit circle. The whole point behind trigonometry, a lot of it is just figuring out different points in different parts along the outside of this unit circle, all of these little dots that I'm filling in. Some of these points are really easy to figure out. For instance, this point over here at 0 degrees. Because the radius of my unit circle is 1, I know that this point, the x-coordinate has to be 1 and the y-coordinate has to be 0. Going around the unit circle, there are 3 other points that are just as easy. Up here at 90 degrees, I know that my x-coordinate is 0 and my y-coordinate is 1. Over here at 180 degrees, I know that my x-coordinate now is going to be -1 and my y-coordinate is going to be 0. Finally, at the bottom of my unit circle here, I know that my x-coordinate again is 0 and my y-coordinate is -1. These 4 points are really, really easy to figure out. Now, we don't just want those 4 points though. I'll actually move back here. I might want one of these points that's right in the middle. So now I'll move down to this other diagram and let's try to figure out the coordinates of this point right here. So if I want to know my x and my y coordinates at this point, it's not going to be nearly as straightforward. I know that my x has to be somewhere in between 0 and 1, but maybe it's like, I don't know, 0.7 maybe? I don't know. And maybe my y, it's like 0.8. I can make a good guess, but I can't be sure. However, if I use some knowledge about trigonometry, I can figure out the exact coordinates of this point on my unit circle. So, first of all, I want to figure out its x-coordinate. I'll make that orange. And I want to figure out its y-coordinate. I'll go ahead and make that this pretty pinkish red color. Okay. They're actually too similar. Let me go ahead and make it, brown. I'll make it brown. So if I take this point and I drop an altitude down, so watch what I am going to do. I'll use the brown marker. You'll see why in a second. I'm going to go ahead and drop this altitude down here. And I have created a right triangle now. So this is my 90-degree angle. This is one side of the triangle right here, and there's my hypotenuse. I know that the hypotenuse is 1 because the radius of my triangle is 1, because it is a unit circle. I know that this height right here from the x-axis up here is going to be my y-coordinate, and I know that this distance here is going to be my x-coordinate. Now I can use my trig ratios to figure out the coordinates. So I know that sine of any angle, sine of theta, say, is going to be adjacent, or SOH is going to be, opposite over hypotenuse. And I know that cosine of any angle, theta, is going to be my adjacent side over my hypotenuse. So I can use that to figure out the exact coordinates of x and y. So if I wanted to figure out, and I know this angle here is theta, if I want to find out my x-coordinate, what I'm going to have to do is I'm going to have to use cosine because x is my adjacent side. So if I want to figure out my x-coordinate, I can say cosine of theta is going to be equal to x over 1, which is just going to be x, because x divided by 1 is x. If I want to find out my y-coordinate, I'm going to have to use sine. So I'll say sine of theta is going to be equal to y over 1, which is just the same thing as y. So right now, what I've proven is that cosine is the same thing as x, and sine is the same thing as y. So I can say that y is the same thing as sine of theta. I can say that x is the same thing as cosine of theta, which means I can represent this point as cosine of theta, comma, sine of theta. Cosine and sine will tell me the x-coordinate and the y-coordinate of any point on my unit circle.